So welcome everyone to this pre-recorded part of the webinar. So today, by the end of this webinar, I hope that everyone will leave with a basic understanding of a digital twin, understands well what it is and especially when it is interesting to use digital twin. So in order to do that, I would like to start with explaining some challenges I see that our customers are struggling with a lot, and also some trends I'm seeing in the market as well. Well, next to that, so if we have covered the main challenges, I would like to explain when it can be beneficial to use a digital twin. So when is it the right moment to use a digital twin, and what can be the benefits of using it. Later on, I would also like to explain in a bit more detail how a digital twin can look like. And to, well, summarize everything together, I would like to close with an industry example. So this is one of our previous projects we did do together with a customer. Well, and I hope it covered everything that I've discussed with you today. So I hope you enjoy. So before, well, I am going to show you a digital twin. I think the most important thing is that you well, have a basic understanding of the challenges that I see in the market, and also have an understanding of which challenges are interesting for a digital twin. So I've listed quite some challenges. They are all on this slide. On the left side are challenges that are mainly related to the production sector. On the right side, it's mainly related to the logistics and warehousing sector, but know that there is also quite a lot of common between the two sectors, so there's not a strict distinction. Well, I will, given the time, I will pick a few, but I hope, well, you will get a basic understanding of the type of questions and challenges we encounter. So if I will start at the top left corner, and I think this is also one of the most important ones. So what we see is that a lot of customers are having problems with finding new skilled employees. So it's very hard to increase your workforce. And on the other hand, a lot of customers need to increase their production. So this also comes with questions. So if I cannot find new or additional employees, but on the other hand, I have to increase my production, how can I organize these? Are there other ways of working? How can we become more efficient in order we can do so that we can do more with the same amount of workers? So that is a question we see a lot. So that's mainly related to improving efficiency, doing work different, other ways of planning. So that's a very important one. Another one I wanted to pick on the production side is the difficulties with redesigning or designing the systems. So what we are seeing is that well, production systems are becoming more and more complex. There are so many processes related to each other. So if you want to make some adjustments in your current processes, or if you want to design even a new production facility, sometimes it's very hard to, well, to make the best design and make sure that you are operating in the most efficient way. So especially given the fact that so many things are related to each other, companies, well, do not know anymore if they are making the right decisions, if this is the best way to go. So also when you have, yeah, you're not sure if you're doing the right thing, you need some support in your decision making, then it's very interesting to use a digital twin as well. On the logistics side, I will also pick two. So if I take the top one, so the limited inventory space. So that's also, well, something we see at many customers. So warehousing are operating at the maximum capacity. Sometimes it is, well, not possible to expand related to the costs or maybe the space. and sometimes it's not needed. So it's also interesting to take a look at what happens if you, for example, change the storage logics. How does it affect the inventory space? What happens if we change the production schedule a little bit? How does it affect the inventory space? How can we optimize the space we currently have? So this is also related to improving the efficiency. And I will pick another one, and that is, well, the pressure to innovate is also something we see a lot at our customers. We had quite some projects related to HVs, for example, so automated guided vehicles. And well, customers are asking whether it is feasible to replace the current reach trucks with automated guided vehicles. And if so, how many do we need? How do they need to drive? So this is also related to if we are making quite huge changes in our warehouses and in our way of working, well, how do we do that, and which decision is the right decision to make? Well, I did not explain all the challenges yet, but if I have to summarize these challenges, well, I think most of the challenges are always related to either the need to become more efficient, so doing the same with less resources, or doing things faster. So that's some efficiency improvement. And on the other hand, what we see happening is that, especially when you're doing some huge investments, companies need some decision-making support. So they need some assurance that they are doing the right thing, but also preventing that they are making some mistakes. So it can be either, or sometimes it's even both in one project. So it can be either improving the efficiency or some decision-making support. So then comes the question, what is actually a digital twin? So in my opinion, a digital twin is a digital copy of the real world. So you have your production facility or your warehouse, and we are making a exact copy of that, but then digital, so on the computer. So this is a very broad definition. So for a digital twin, we have 4 different levels of detail we can bring into a digital twin. So the first 2, so it can be on the production plant level or on production cell level, and those are mainly related to including all the processes, the operations, the product flow that are happening at a site, also in a digital twin. So that's on the production plant level, so including all the production cells, all the processes, or we can zoom in a bit and make a digital twin of your production cell. And a digital twin on the production cell, is often a bit more detailed than a copy on the production plant level. So production cell level digital twin contains all the movements, for example, that are happening in a production cell. So that is mainly related on the process level. But then, for example, we can also make a digital copy of your end product. So then you can see digitally how your end product will look like. So which components is it built up? Where are the molds located? So then you can see everything in 3D. And then, your end product is built up out of components. So you can also make a digital twin on your component level, and then you can see your components. So that are the 4 different levels of a digital twin. So what is that actually a digital twin? So I hope we can cover this in this drawing. So this is the most technical part of this webinar, and after this, I hope you will understand the basic understanding of what is a digital twin. So what do we see over here? So over here, so this currently is your production plant or your warehouse as it actually is. So this is the real world. So what we can see over here, these are the products it contains. So it's end products or its components. And over here, this is mainly related to its processes that are taking place within a facility. So what we are aiming for with a digital twin is to make an exact copy of what is happening in the real world. So this is what you see over here. This is a digital world. Well, it is basically the same. Well, if you have a perfect digital twin, it's one-on-one doing exactly the same. Well, so what are we doing with a digital twin? And this is also where we will focus on this webinar. We are focusing on the production side and production cells. So that is mainly process focused and making a copy of what is happening. So we are using Plant Simulation for this. So this is a tool made by Siemens. And this is a video of how it can look like. So this is basically to show you the visualization. So what you can see, for example, happening, there are trucks coming in, products will be brought to the inbound goods, they can be stored within a warehouse. Later on, they will be retrieved from the warehouse. Well, so this is to give you a first impression. Know that within a digital twin we can visualize almost everything. We can include many different kind of processes, and we can keep track of everything. Well, maybe a little bit more theoretical, but it's always a statistical model, so which means you can measure quite a lot in a digital twin. So then comes the question, so why would I use a digital twin? Why is it interesting to do that? So, well, I took one of our last projects as an example. So the one on the left was a customer that also had some problems with finding enough employees. And what they do, they decided to build a digital twin of their current processes and to test whether it's interesting to organize work a little bit different. So to change the process sequence a bit, but also the planning. And the result of this project was that they could reduce the number of FTE that was needed in a production process 30%. So this is quite a lot, and this also resulted in the fact that they can increase the current production with the same amount of resources. So which was a very good result of this project. Well, another example, this was a customer willing to buy some automated guided vehicles within the warehouses and to do the transport of pallets within the warehouse itself. And they already had a supplier of the AGVs in their mind, but they weren't sure if they made the decision for the right amount of HVs that were needed in the processes. So what we did do, we built a copy of their warehouse. We did bring in the new, the HVs, with their characteristics related to the speed, how they can drive. The first result of this project was yes, this amount of HVs is feasible. You can replace your current processes with these HVs. But next to that, we did some additional scenarios where we said, okay, we think we can even reduce the number of HVs that is needed if we can change some of the task allocation logic, but also the driving routes and the grouping of the HVs. And by doing that, we could reduce the number of HVs that is needed with 18%. Well, that were some examples, but then also the question, so how is this possible? So how does it actually work? So what we have, so this is, for example, your current system or a system you are willing to design. So what we try to do with a digital twin is to make an exact copy of your system with its processes, all the characteristics included. And what we can do with the digital twin is we can simulate over time, and we can gather a lot of statistics. So what does it mean? You get a constant feedback loop. Well, it's also a continuous improvement process. So we get some new insights, we get some logic, test it again in the model, and if we are sure we are doing the right thing, you can include it in your system and make it even better. And so it's a back and forth working in which you can really improve your systems. Well, so now that you hopefully have an understanding of a digital twin and how we use it in our projects, I would like to also give you an industry example. To give you even a better understanding of how it can be used in practice. So the case I would like to tell you a little bit more about is our Mr. Mallow case. So Mr. Mallow is a marshmallow manufacturer in Europe. It's even the biggest one in Europe. They produce over 20k of tons of marshmallows per year. And they have 3 production locations in Europe. Well, Mr. Mallow came to us. They decided to close one of the production facilities, but it didn't mean they wanted to stop the production. It did mean that the production of one facility had to be brought over to one of the other facilities. So this meant an increase of production of 70%, and well, their question was, how can we do this? How can we prepare for this? Which steps do we need to take? So that is the question they had. So I will show you the simulation model, and I will also give you, a basic understanding of the flow we were dealing with. So this is a video of the simulation model we built. So what you can see on the right side, there are 3 quite big silos within the frame. And those silos contain the most important raw ingredients to make a marshmallow. So this is water and 2 types of sugar. So what is happening? Over there we store the raw materials, and the raw materials need to be transported to some smaller tanks. If we wait, over here we can see the cooking kettles, we call it, and over there we make a so-called premix. So the first raw ingredients are mixed. Once it's done, and it needs to be transported through the pipes to the other kettles. When the pipe colors up, it means some product is flowing through it. Over there we add some other raw materials, mix it again, and once it is ready, it will be transported to the latest buffers, and then we can really start with producing a marshmallow. So on the left side, all the products you are seeing there, those are the marshmallows that are being produced. And the question of Ms. Mallow is mainly related to the planning. So it's quite complex. They are producing quite a lot of different types of marshmallows, and you need to make sure that the kettles are empty before you start filling up with another type of product. And also for the production lines, you want them to be operational as much as possible. So it's mainly related to efficiency improvements. So in the beginning of this webinar, I told you that most of the projects are related to improving efficiency or decision-making support. Well, this project covers both. So how we build a simulation model, we have a copy of their processes, and what we could do with that model, we could run different scenarios, and there were 4 important parameters we could change in order to come to our answers. So the first thing we could do was how we could increase the planning. So in the end, we had to increase the planning up to 70%, but we decided to do it gradually and see its effect. What happens if we increase the planning with 10%, with 20%? So that was one of the first things. The second thing we try to do is to optimize the planning, and we did play around with some line balancing. So this one is really related to improving the efficiency in your plant. And the last 2 are related to some investments. So they had 2 things they could choose from. They could either adjusting the width of 2 of the production lines. So by doing that, you could increase its capacity of the production line, or they had the option to buy an additional production line. So this one is of course the most expensive one, but we had to test if we increase planning, when do we need to buy a new production line, or can we maybe adjust the width of one of the lines? What is the best option to go for? So what do we see here? So this is the outcome of the different scenarios we did run. On the left side is the baseline scenario. So this is the as-is scenario. So they were currently operating on 73% of their capacity. And you also see in the rest of the graph, you see a 100% line. They didn't want to reach the 100% line. So what you can see, for example, so if, for example, we increase the planning with 80%, then we are operating at 91% of the capacity. And by, doing different scenarios, we could see, okay, so if you do some line balancing now, then we are reducing the capacity with this amount of percentage. If you broaden the lines, well, then this is the effect on the capacity you're operating at. And by doing that, we could really give them a good understanding of when do they need to do extra tasks. So after this simulation project, so what were the most important outcomes for Mr. Mallow? So I think the first of the important outcomes is that they currently have a very clear understanding of their 5-year investment plan. So they know exactly, so if we are increasing the planning with this percentage, then we need to broaden the lines, or then we need to make these adjustments in order to make this work. So they can really prepare their plans for increasing the planning. Well, and another thing that was an important outcome, which I think is the most important outcome, is that we could very easily play around with some line balancing within the simulation model, and by doing that, we could really postpone the need to buy an additional production line, and this really reduced our investment cost. So even for the first years, they are fine with just some optimized planning, and by doing that, they can still achieve the planning they want to. And the last thing, I think it's also a very interesting outcome, especially since this wasn't really an unexpected outcome. So they came to us with a question, so how can we improve our efficiency Are we doing the right things related to the investments we want to make? So those were the questions we could answer. But as we are able to upload the production plans within the simulation model, they are still using the simulation model every week. So at the start of the week, so when there's a new production plan available, they are uploading it in the simulation model, and they are checking whether the planning is feasible or if they need to make some adjustments. So that's a very interesting outcome on top of this project as well.